Hello everyone, in this video we will see these two problems depends on the argument of complex number. See, first one is if modulus of z minus 25i is less than equal to 15. So this is the famous locus in complex geometry. Okay, this represents circle with center at 0 comma 25, that is in y-axis. This is y-axis, and here suppose that I am having here I am having 0 comma 25, correct? So I am having a circle like that. This is your circle, correct? This is your circle. 0 comma 25 is a center and radius is 15. Radius is 15 means this distance is 15. If this distance is 50 and this whole distance is 25, therefore this is 0 comma 10 and this is 0 comma 40. Okay, this is very common. And less than equal to 15 means your z lies either here on circumference or your z lies inside the circle, correct? That is the point. Now if I say that z is lying over here, okay, then this z has, say this point is A, this z has minimum argument, this z has minimum argument. So this is your argument of this z, and if this z is lying over here, that is B, then this z has the maximum argument. This point is very clear. Now coming to the concept of triangle. Now coming to the concept of triangle and circle and tangent, every concept of coordinate geometry we will apply over here. How? See, this is tangent to this circle at this point, okay? So from center, if I join this point of tangency, so therefore this angle will be your 90 angle, 90 degree, okay? And this triangle is a right angle triangle, correct? And similarly here, this is the point of tangency, this is the tangent to this circle, therefore this angle is also 90 degree, and this is the radius is given as a 15, so this is 15, correct? This is also 15, so these two sides are same in these two triangle, this side is common, and these are right angle triangle, therefore these are symmetrical triangle. So finally you can say that this angle and this angle are same, okay? By symmetry these two angles are same. Suppose this angle is alpha, and this angle is also alpha. Now by symmetry we have to find out the maximum argument and minimum argument of a complex number z which satisfy this locus, and this locus is a circle, that z is lying on circumference of circle or inside the circle. Then we have to find out that z which has minimum argument, that z which has maximum argument, and then we have to find out the difference of this minimum and maximum argument, correct? Now if this is alpha, then the minimum argument z will be pi by 2 ka minus alpha, correct? This is your argument, okay? And this whole angle is pi by 2 and this angle is alpha, therefore this is pi by 2 minus alpha, and therefore maximum argument of z which satisfies this locus is pi by 2 plus ka alpha, and therefore their difference, if I say that therefore modulus of maximum of argument of z minus minimum of argument of z is pi by 2 plus ka alpha minus pi by 2 plus ka alpha minus minus plus. So that will be 2 alpha. Finally, you have to find out the alpha. Then you can find out the 2 alpha. Alpha can be find out. Now look at the options. In options, we are having sine inverse and cos inverse. Here comes the concept of again that trigonometry triangle. Correct? See, look at this triangle. This triangle I am drawing over here. Okay, I am drawing over here. This is your 90 degree. Correct? This is your 90 degree. The length or hypotenuse that is opposite to 90 degree is 25. So this is 25. Got it? And the length which is opposite to alpha, suppose this is alpha. Alpha opposite is radius. Radius is how much? 15. So this is 15 and definitely this will be Pythagoras theorem 20. So this 15 can be written as in lowest form 3, this can be 5, this is can be 4. 3, 4, 5 wala triangle. Correct? 3, 5, 4 wala triangle. So I want to find out alpha and sine inverse you have to put. So sine alpha. So it is sine alpha. Sine alpha means opposite by hypotenuse. Alpha opposite is 3 and hypotenuse is 5. So therefore alpha is sine inverse of 3 by 5. Therefore 2 alpha is 2 sine inverse of 3 by 5. So 2 sine inverse of 3 by 5 is your answer. Now look at this second question. Now you can solve the second questions and you can answer the second questions verbally. Okay. See the same locus, z satisfied this locus, same one. Modulus of z minus 25 iota is less than equal to 15. So therefore this is a circle with center 0, 25, radius is 15, z lies inside or on the circumference of the circle. Okay. Okay. Now you have to find out the complex number having least positive argument, least the maximum positive argument, having least modulus, having maximum modulus. So from here you can directly this question can be very easily answered now. Least modulus. Least modulus means z lies over here. Then only we can have the least modulus. And this point was this is 0, 25, radius is 15. Therefore this is 0, 10. That is that complex number is 10 iota. Correct? And the complex number z which has the maximum modulus is 40 iota. You understand? Now you have to find out the least positive argument. Least positive argument means this one and this one. Got it? So pi by 2. Here now I am deleting this and again I will make the figure. Okay. So what is that? This is your circle. This is your 0, 25. This is your 0, 40. This is your 0, 10. Correct? Okay, fine. Now this is your z. This is and this is. Okay. So this is maximum argument wala z. This is minimum argument wala z. This is your alpha. This is your alpha. This angle is 90 degree. This angle is 90 degree. Why 90 degree? The concept of coordinate geometry, you know, circle. This is tangent. This is point of tangency. This is center. Okay. This side is same to this triangle. This sides are same. So by symmetry, this is alpha and alpha. So therefore, minimum. See now, minimum argument of a z will be pi by 2 minus ka alpha. Now alpha we have find out. Alpha here. This is 90 degree. Opposite side is 25. This is alpha. Opposite 90 degree opposite is 25, alpha opposite is 15, correct? Radius is 15, so therefore this is 20. You can see that this is 5, this is 4, this is 3. So therefore alpha is, now I can find out alpha by using the sine concept, or by using cos concept, or by using tan concept. Correct? So alpha is, see, tan alpha is 3 by 4, और sin alpha is 3 by 5. So यहाँ से alpha is tan inverse of 3 by 4, and this is same as sin inverse of 3 by 5, and that is same as cos inverse of 4 by 5, like that. Okay, fine. So therefore we are having minimum argument of z. So minimum argument of z is pi by 2 minus, if I say that tan inverse of 3 by 4, so this is your answer. Or you can say that pi by 2 minus sin inverse of 3 by 5, this is your answer. Pi by 2 minus cos inverse of 4 by 5. And now pi by 2 minus tan inverse 3 by 4 can be written as cot inverse of 3 by 4. By using the inverse trigonometric concept, that cot inverse of 3 by 4 is written as a tan inverse of 4 by 3, because this x is greater than, if cot inverse of x or 1 upon x can be written as 1 upon tan inverse of 1 upon x, or tan inverse cot inverse of x is equal to tan inverse of 1 upon x, right? When, if x is greater than 0, correct? Fine. So therefore pi by 2 minus tan inverse 3 by 4 is equal to cot inverse 3 by 4 is equal to tan inverse 4 by 3. Now coming to the maximum argument. Yes, maximum argument of z is pi by 2 plus ka alpha, pi by 2 plus tan inverse of 3 by 4. Now tan inverse of 3 by 4 can be written as pi by 2 minus cot inverse of 3 by 4. So this is pi minus cot inverse of 3 by 4. Got it? Pi minus cot inverse of 3 by 4. This cot inverse of 3 by 4 can be written as pi minus tan inverse of 4 by 3 as well. So this can be your option. This can be your option. And similarly pi by 2 plus sin inverse, pi by 2 plus sin inverse of 3 by 5 can be your option as well. Correct? So I hope that here we have used only the basic concept of argument of z. Rather, the most important concept we have used is that locus. That is, this represent a circle with center at 0, 25, radius is 50, and from this we can say that this z, if z lies here, then that will have the maximum modulus. If z lies over here, that will have the minimum modulus. If z lies over here, that will have the least positive argument. If z is lying over here, that will have the maximum argument, correct? Maximum positive argument. And of course they can ask that to use the concept of inverse trigonometry also, correct? So very nice question.